Here is part 2 to the original video covering the bowditch adjustment in TBC. This is the traverse as it was left. If I look under Traverse Networks in Project Explorer, here is the loop traverse, which starts and ends with the only fixed point being L2. So L2 is the starting station and also the station the final foresight closes onto. If I go over here, you can see that this is an enabled traverse, so this is active and providing coordinates for this project. If I right click here, I can disable this traverse and create a new one, or I could choose adjust traverse and make some modifications to the traverse as it currently exists. So I think I'll go to disable traverse just to show how that can be done. Notice how the graphics change in the plan view to illustrate that we're back to the original tilt station measurements now, and there's no traverse network applied to them or traverse adjustment applied to them. So I'm going to go back to the survey ribbon and go to adjust traverse, and this time I'm going to create a new traverse. Still starting at station 10, L2, but the difference this time is that I will fix another station along the route. So in other words, the loop is going to pass through another coordinate as it goes around the loop, which will be at L6. L6 does have control quality, but in the previous video and processing it was set to enable as check. So I'll switch it back to fully enabled within the project and recompute. So I'm going to begin building the traverse loop now using the adjust traverse dialog. So we're going on to L4, yep, and then it closes round. So it's gone from L2 through L6 back to L2. So we have a single foresight from L10 back to L2, and the backside for the orientation of the loop is to L1, so that's all fine. We'll set the adjust vertical to equal proportions as well. It's on the bowditch method. Look at the preview results. You can see this time we're going to get somewhat different values because the introduction of L6 is going to affect the distribution of the internal angles within the observed loop. So here we can see that the angular misclosure is now 25.4 seconds, so a little higher. In the previous processing, without the inclusion of L6, that number was down near 7 to 8, between 7 and 8 seconds. But bear in mind that these are GNSS derived coordinates and thus won't have the same level of precision in them as the tilt station observations. But it's useful to see how it is possible to fix additional control within a loop traverse if it's available, even though in this case it's based on GNSS, points with GNSS precision and not anything more precise. So we've got our easting and northing misclosure values here and the vertical misclosure. So traverse length and the horizontal precision. So still not terrible by any means. So after angular misclosure, this is down to 0 now because the misclosure has been adjusted out. Still got some distance misclosure of 9 mm, and the horizontal precision is now approximately 140,000, and then that last 9 mm is adjusted out of the distances between the stations in order to compute new coordinate values. So we could go ahead and apply that traverse. Just close this up. So the stations along the route will now have traverse adjusted coordinates, apart from L6, which will have its original control value. You can see we've got a traverse fail tolerance warning here. So in my settings, I have a traverse horizontal precision value which is greater than this. So this one is flagged as failed, although at 1 in 40,000 it's still not terrible by any stretch. And then L7 has an out of tolerance message on it, which again means that coordinates possible from the input data for L7 disagree by a predefined amount. So if you want to check what these tolerances are, then project settings is the place to do that. So if I go to computations and point tolerances, I can see that for survey quality points, then any observations or coordinates or entries for a point that we're provided with a coordinate, if they disagree by more than 20 mil horizontally, then they're going to get flagged, as is the case here for L7, where the various source data that could provide a coordinate for L7 disagree by more than that 20 mil threshold, indeed closer to 29 mil. Now, in terms of the traverse setting tolerances and so on, if we go on to here to traverse, you can see that the minimum horizontal precision setting is currently set to 1 in 50,000. Thus, the value for this particular traverse of 1 in 40,000 is showing up with a warning flag because it is not as precise as the minimum horizontal precision setting here. You can also see in here some other tolerances that relate to traverse adjustment as well. Okay, so let's see what's going on with L7, and for that we use the point derivation report, very useful report. If we right click on L7, let's open the point derivation report. I'll bring it across to my screen here. And we can see that we've got a total station observation from L6 to L7, which is hanging off the bottom of the Bowditch traverse adjusted loop. And we have a GNSS derived coordinate for L7 as well. Okay. Now, the final coordinate for L7 is being taken, well, it would be being taken from here if it was set to control quality, but it's still set to check quality. But we can see what the discrepancy is between the two sets of values, 21 mil in easting, 19 mil in northing, and actually not much in elevation at all. So what I could potentially do, if I want to fully update the coordinate for point L7 based on the total station measurements and the traverse, then I could fully disable it, or if I want to fully keep the GNSS derived coordinate, then I can set it back to enabled. Just a reminder where that's done. So I go under L7, here is the coordinate that's coming from a CSV file containing the GNSS post-process value. It's currently set to enabled as check. It's done in the first video. So if I want to keep that value as is, I would set this to enabled. If I want an updated coordinate for L7 based on the traverse adjustment, then I would set it to disabled. Just demonstrate what happens if I do that. So it's disabled. I'm going to press my reprocess button, and I now have an updated coordinate for L7, and that warning flag about the mismatch in computed coordinates failing the tolerance has now disappeared. So there we go, that's the end of the video. It's a short one this time, showing how it's possible to fix additional coordinate positions in a loop traverse within the loop other than the start and end stations.